when connecting SPI devices to the Raspberry Pi. They provide two chip select lines on the Raspberry Pi. That means that you can connect two SPI devices to the Raspberry Pi without having any extra circuitry involved. But I'm getting to the stage where, because there's so many good SPI devices out there, where I want to connect more than just two SPI devices. So what I've done on this project is I've got a thing called a line decoder down here, and what that does is it turns a binary number, say, so I use one of the chip selects and I use a GPIO pin off of the Raspberry Pi. So that gives me two address lines, and it decodes that binary number into four individual lines. So so I can then select up to four SPI devices. So on this circuit at the minute, I've got at the very top a display, which is an SPI device, and down the bottom I've got an analog to digital converter there and an analog to digital converter there. So that's three SPI devices. But I've also got two more SPI devices, which makes up five SPI devices. But the good thing about these ones, and what they do is, these are SPI GPIO extenders. So each one gives you an extra 16 GPIO connections. But they also have things called address selects. So they have 3 address lines per one. And what you do is you just hardwire, although I've got jumpers on here so I can manually select the addresses for when I'm testing, but you would hardwire this as address 0 and this is address 1. So on the single SPI line, you can have up to 8 of these chips addressed. Unfortunately, analog to digital converter chips don't have address lines, so you can only really connect one chip select for the SPI device onto each of those devices. So what this means is, because I've got a 2 to 4 line decoder, I'm using one GPIO pin off the Raspberry Pi with the chip select for the SPI device, which gives me 4 devices. You can also get 3 to 8 line decoders. So in the place of this, I could put a 3 to 8 line device and use 2 GPIO pins off the Raspberry Pi plus a chip select. I would get then up to 8 SPI devices which I could connect. Or you can even get a 4 to 16 line decoder. So if I use 3 GPIO pins off the Raspberry Pi plus a chip select for the SPI, I could address up to 16 SPI devices. So what that means is for these analog to digital converters, if I just use those with a 4 to 16 line decoder, I could have up to 16 of these 8 analog to digital converters. Each one of those has got 8 lines on it, so I could have up to 128 analog to digital converters going into my Raspberry Pi. Or if I just used these chips, the GPIO extenders, I could have up to 8 of these to be addressed. So and then 8 times the 16 lines coming out of the decoder, and then there's 16, which gives 128 chips I can connect to this. And then if you take into account that each one of these has 16 GPIO lines, that would give you 2048 GPIO lines that you could connect to the Raspberry Pi. I mean, your board would have to be quite big because you'd need 128 of these chips, but it could be wired up really simply. Because one of the advantages of the SPI device is that you only have really 4 lines of communication going to each chip, and they're the same lines of communication. The only different lines that you have is the chip selects, which you would have to wire up individually, and the address lines would get wired just locally as well. They just get hardwired, or you could put you could put these jumpers on there if you wanted to manually reassign them, but there's no need to do that really. So with this the board as it is, I've got the GPIO lines that I've added coming out of these headers, and I've got the analog to digital lines coming out of these headers. I've made up a couple of test circuit boards. So this one's got a variable resistor on it for an input to the analog to digital converters on this lower board, and it's got some LEDs to show outputs from the GPIO extensions. So if I add this board, and hopefully I won't short anything out when I'm added it because it's turned on at the time. And you can see the, just push it down, and you can see the outputs are currently running on the GPIO extender at the top. And this line, this screen's brightened up now because what I'm doing is I'm using this variable resistor to feed an analog to digital line, and then I'm using that to set the contrast of the display. So when I turn this, I can turn the contrast up or down on the display, which is just a demonstration of the analog to digital converter I run in the display. There's a little graph running along the bottom of the display. At the minute that's just showing noise, which is the analog to digital inputs on this chip. And I've created another little test circuit to go on that side. So this is just a simple 2 transistor flip-flop, so it just alternates between the 2 LEDs. And I'm taking lines off of here, and I'm going to run those into the GPIO pins on here, and also into the analog to digital conversion. And then what I do is I graph it, how it happens up there. So the graph up here will change into an actual signal when I put this board on, and hopefully again I don't short anything out when I'm putting this on. Okay, so the flip-flop's flipping and flopping, and the analog to digital signal that I'm displaying at the top of on that board is the capacitor, one of the capacitors it's charging and discharging. So you can see that going across there. So on that display, I'm displaying the time and date at the top, and just an example of a font on there, and it's using the smallest font unfortunately that I've got. So I haven't put bigger fonts on there, but that's something I need to do. I need to write some bigger fonts for that. And I'm just drawing some graphics below that, just an example of line drawing and drawing boxes and filled boxes and circles. At the bottom I've got the graph plotting, and just above the graph it's showing that I'm getting about 46 frames per second on what it's doing there. So I might have a go at writing the game as an example of driving that board for a later video. So what I'm going to do now, I've got this example program which is running, which is written in C. I need to convert this into a device driver for Linux, and then I will be able to drive that from a Python script, and I'll publish a full write-up on this project when I've done that, and I'll demonstrate the running these SPI devices through the device driver using Python, so that you can extend your I/O using SPI in Python to get as many I/O ports as you want, and as many analog to digital ports as you want, and to add these displays as well. Because in theory you could add several of these displays if you wanted. So I've got a 2 to 4 line driver, so I could add 4 of those displays.